we're going to start seeing equations that have more than one letter.
Holy alphabet.
This one has X and Y, 2 letters. And they can be A and B or other letters, but usually it's going to be X and Y. And the answers to these equations are going to come in pairs. Some of them are going to fit, if you would. And let me show you some that don't fit, because most of them don't fit. Let's just pick some arbitrary pairs. 1, 5. Now, I'm going to put the numbers in alphabetical order. So I'm going to put the first one in for X all the time, and the second one in for Y. Note that the 1 went in for the X, and the 5 went in for the Y. And 1 plus 2 times 5, or 1 plus 10, does equal 11.
Okay.
So that is an N answer to that equation. But I don't want you to think it's the only answer. The pair 5, 3, put a 5 in for X and a 3 in for Y, is going to form 5 plus 2 times 3, or 5 plus 6. And that also equals 11.
Oh, yes.
So we've got another answer. Well, are they all answers? Well, let's just take another number. 4, and I'll go in for X, and 2 for Y. 4 plus 2 times 2. 4 plus 4 isn't 11.
Nothing for you.
So they don't all fit. Can you use a negative? Well, let's see. Put a negative 1 in for X and a 6 in for Y. Negative 1 plus 2 times 6, or negative 1 plus 12. Yes, it works.
Yes.
You can put negatives in, as long as they work. Now, they don't always work. If I put a 5 in for X and a negative 1 in for Y here, well, 5 plus 2 times negative 1 is 5 plus negative 2. That's going to not equal 11.
Survey said.
So they don't all fit. I hope you get the idea. Let's look at another 2-variable equation and see if you can notice some similarities. Y equals negative 3 plus 2x. Okay, once again, we have 2 letters, Y and X, or X and Y. But I'm still going to put the X in first. And there will be some that fit and some that don't fit. For instance, 4, 5. Now, what am I going to put the 4 in for? Be careful here. The first number always goes in for the X. The 5 is going to go in for the Y because it's second. And negative 3 plus 2 times 4, or negative 3 plus 8, does equal 5. So that is a solution to this equation. It's not the only solution. 0, 2. Let's see if that's a solution. Put a 0 in for X and a 2 in for Y. Well, 2 times 0 is just nothing. And negative 3 plus 0 does not equal 2. So that one...
Way off. I say you're way off this time.
No, that one doesn't fit. How about 1, negative 1? Let's put a 1 in for X and a negative 1 in for Y. Well, let's see. 2 times 1 is 2, plus negative 3. I'm working backwards. 2 plus negative 3 does equal negative 1. So it works.
Hey, this is great, man.
Put it in the good pile. Can you use fractions? Absolutely. Or decimals. 1.5 and 0. Let's put 1.5 in for X. And 2. Do you know what 2 times 1.5 is? Well, it's 3. And son of a gun, 3 and negative 3 do equal 0.
Totally.
So we're not going to discount anybody just because they have decimals or fractions or anything. How about this one? Let's put a 2 in for X and a 3 in for Y. Well, 2 times 2 is 4, and 4 minus 3.
No way.
That one doesn't work. Most of them don't work, actually. How about this one? Put a 2 in for X and a 1 in for Y. That's going to be 2 times 2. I have to do the multiplication first. 4 minus 3.
Yes.
That one works.
Now what am I going to do?
And we've been showing you that some fit and some don't fit. You can make them fit. For instance, if I give you the coordinate 2 for X, you can find the correct Y so that to make it fit. What will I do? I'll put a 2 in for X and then I'll solve the equation for y. Remember how to do that? 4 times 2 is 8. Now we have to get y alone. What will we do? Subtract 8 from both sides and divide by 2 to get y alone, and y in that case will be 4. And you made it fit. You found a solution to that equation, the ordered pair 2, 4. Now how's that different from the next point where the 2 is the second coordinate? Well, now that 2 represents the y, so I'll have to put it in for y and solve the equation for x. In this case, 2 times 2 is 4, and I'll have to get x alone by subtracting a 4 from both sides and then dividing by 4. And it looks like in this case the point will work, or the pair will work, if x is 3.
You're absolutely correct.
Now I'm jumping back and forth so you'll remember that the first value is x and the second value is y. So let's do the next one. What are we going to put the 5 in for?
You'll come again.
We'll put the 5 in, since it's the first value, we'll put it in for x. And then we have to find y. You're going to get good at solving equations. 4 times 5 is 20, and let's solve for y. We'll subtract 20 from both sides. Remember, 16 minus 20 is going to be a negative number. Nothing wrong with negatives. Then who's keeping y from being alone? The 2. He's multiplying, so I'll divide. And in this case, another solution will be, if x is 5, y has to be negative 2.
Sheer, unadulterated brilliance.
It's not that hard. Now 0 is very easy to deal with. Let's look at the next pair
Whoa!
and put 0 in for y, because it's the second coordinate. I love 0 because it just cancels out. 4x equals 6. Don't even have to get rid of it, do we? Divide by 4 kind of saved me a step, and x is 4.
You are correct, sir.
So remember that 0 is going to be very easy to deal with. So we've found 4 points that are solutions to this equation.
Do you mind telling me what this is all about, mister?
Any ordered pair can be drawn on what we call a rectangular coordinate system. Let me show you what it looks like. There's what we call the x-axis. In the middle is 0. To its right is the positive values of x. And of course to the left is the negative values of x. They work their way down. Now this is a rectangle, so we need another axis, we call it. And that's going to be the y-axis. It still has a 0. The positives in this case are going to go up. That's logical. And the negatives are going to go down. Hopefully you can see, and it goes on forever. It doesn't stop at 10 like this picture, or 6. Basically what we have here is a giant rectangle, an infinitely large rectangle. So hence the term rectangular coordinate system. Now, we can actually draw that pair as what we'll call a point. What we do is we start at 0.
It's always best to start at the beginning.
We call that the origin, and we do our execute our x value first, which is 4. Don't draw anything yet. And then from that position, execute your y value. From that position, we're going to go 5 in the positive y direction. And now we're at our position, and we draw the point. It's called the point 4, 5. How about the point 3, 6? Well, once again,
Start at the beginning.
start at we call that the origin, the 0, 0 point. Do your x over 3, don't draw anything yet, and then from there, go up 6. Up because it's positive, and there's your point. Oh, this one's a little weird, but we can do it. Actually, we're going to do the same thing.
Start at the beginning.
We're going to start at the origin, go over 5, and how much do we go up? Go up none. So that's where the point is. We even say that's on the x-axis. That's the point 5, 0. Don't be afraid of 0.
Uh-oh.
What about 0, 2? Where is that going to end up?
I know that, dude.
I know we start at the origin. We go over none and up 2. And that's where we end up for 0, 2. That's the point 0, 2.
There's something screwy around here.
What about negatives? No problem. Still start at the origin, but this time you go back 2. You go in the negative direction for x, and from there, well, this is a positive for y, so we'll go up for y. And that's where our point ends up. Let's do another. That's double negatives. Where's that going to go? Well, we're going to start at the origin. For x, we're going to go negative 5. And for y, where do you go for y negatives? Go down. And that's the point, negative 5, negative 3.
This is a pickle, George. This is a pickle.
Doesn't get any harder than this one. We'll start at the origin. For x, we'll go back 4. And then for y, where do we go? Y is 0. We'll stay right there. There's your answer. Now, I hope you appreciate we can actually represent any position in this infinitely sized rectangle with an ordered pair. We'll call it a point. But don't be confused. A point actually has to have 2 values. We call them the coordinates. The first coordinate is the x, and the second coordinate is the y.
Who cares?
Well, if we look at, let's go back to our equations and look at all the points that fit, or some of the points that fit into this equation. Here's some that we found that fit. 1, 5 fits. 1 plus 2 times 5 equals 11. So it fits. Let's plot 1, 5. We go over 1 and up 5. 5, 3 fits. Think 5 for x and 3 for y. 5 plus 2 times 3, that fits as well. Let's plot it. Go over 5 and up 3. Actually, negative 1, 6 fits, doesn't it? We did that before. Negative 1 plus 2 times 6 is negative 1 plus 12 is 11. And if we plot that, we start at the origin, go back 1 and up 6. It ends up right there. Did you notice anything?
Cool.
All the points that fit in here line up.
Great horny toady.
And there's way more than that fit in. But every point that fits into this equation, even the fractions and the zeros, there's an infinite number of them, lie right on that line. And in fact, they form a line. That's why we call this a linear or linear equation. Pretty cool. They line up. Okay, go practice your homework, and I'll tell you a little bit more next time.